Greatest common factor. I'm going to show you two methods to find the greatest common factor. The first one is the list method. So when creating a list, you're going to write all of the factor pairs for each number. Here I'm finding the GCF of 56 and 72. So I'll start with the factor pairs of 56. 1 times 56, 2 times 28, 4 times 14, 7 times 8. Then I write those factors in an ordered list. I'll do the same thing for 72, but it has a lot more factors. So I write out all my factor pairs: 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9, and put all of those numbers in an ordered list as well. Now that I have both lists of factors, I can look for factors that both numbers have in common. So I see that 1 is a common factor, 2 is a common factor, and 8 is a common factor. The largest of these common factors is 8, so my GCF is 8. Okay, that's the list method. Now I'm going to show you the upside down birthday cake method. So I'm going to find the GCF of the same two numbers so that you can see both methods with the same pair of numbers. So I'm going to write my two numbers, 56 and 72, and I'm going to write them side by side. And then I'm going to have what sort of looks like the division house that you draw, but it's upside down. And I want to think of any number that goes into 56 and 72. So when I say into, I'm talking about divisibility, right? So both of these numbers are even. So I know 2 goes in with no remainder, right? So 2 goes into 56 28 times, and 2 goes into 72 36 times. And now I'm going to repeat the process. So what number goes into both 28 and 36 with no remainder? So both of these numbers are multiples of 4. So I know that 4 goes in, so I'm going to divide each one by 4. That gives me 7. 36 divided by 4 gives me 9. When I get to this point, 7 and 9 have no common factors. In other words, there's no number that I can think of that goes into 7 and 9 without a remainder. So that means that I'm done. So I take these two numbers over here and I multiply them, and that's my GCF. So much shorter method than writing out all the factor pairs for each number and then writing them in order and then finding the common ones and then finding the greatest, right? So in doing this method, we're just looking for as large of a number as we can think of that goes into both numbers, and we're just continually dividing. Let's try it with another pair of numbers. So let's try 90 and 144. Okay, so I'm going to start off the same way, right? I'll have 90 and 144. I'll write them side by side and think, what goes into 90 and 144? Well, again, I know they're both even, so I can divide them both by 2. 2 and 3 are usually good ones to start with. So 2 goes into 90 45 times, and 144 divided by 2 is 72. 45 and 72. What number goes into 45 and 72? Well, these are both multiples of 9. So I could divide them by 9, right? 9 into 45 goes 5 times. 9 into 72 goes 8 times. 5 and 8 have no common factors. So my GCF is 18. 2 times 9. Now, you're probably thinking, okay, but what if I didn't know that 9 went into both of those numbers? Well, that's okay. You'll still end up with the same answer in the end. So let's try it a different way. Let's say I divided by 2. 2 goes into 90 45 times. 2 goes into 144 72 times. And maybe I looked at these and I said, man, I don't know, but I know 4 plus 5 is 9, and that's divisible by 3. I know 7 plus 2 is 9. That's divisible by 3. So I know 3 goes in, right? 3 goes into 45 15 times, and 3 goes into 72 24 times. And now I've got 15 and 24, which are also divisible by 3. And I get 15 divided by 3 is 5. 24 divided by 3 is 8. And now I got to that same 5 and 8 that I got to the first time. They don't have any common factors, so I'm done. So now I'm multiplying 3 numbers to get my GCF. But 2 times 3 times 3 is still 18. So whether you are able to see the largest number that goes in right away, or you keep chipping away at it by dividing it by small numbers, you're going to get to the same answer in the end.